Yeah, my name is Joshua. It's my pleasure to welcome every one of us to how to visualize our time series data using R. So straight away, we shall be going to our R studio for the sake of people that peradventure you are a beginner in the use of R and R studio. Usually the starting point is for you to search your working directory. Your working directory is just a folder where you have your stuff. And for you to set the working directory, you click here, session, set working directory, choose directory. Like in my case, I'm using uh, my time series analysis training folder. It's on my desktop. So you click open here. So you've done that. These are various files in the folder. Usually, R has so many packages. I think by now it should be up to 10,000 or more. So when we are learning R, we are actually learning packages that are relevant to our discipline most of the time. So there are some packages that are very relevant to time series analysis. Um, some of the packages that we shall use in the course of this training include tidyverse to manipulate our data sets, tidyquant for manipulating time series, forecast to plot a graph and to make forecasts, date to manipulate dates, zoo for to manipulate time series dates, and we have write Excel to export our data set to Excel. We have ggpub for adding trend equation and coefficient of determination to our graph. Then later we shall use URCA to perform unit root tests. Then we need a reader to import CSV dataset. The data that we shall use, that's COVID data, is located in um, our wordindata.org, covid.ourwordindata.org. Let me show us the sites. So um, so let's minimize this so that we can be able to see the site. So this is COVID. So this is the website. So this is data on COVID-19 by our word in data. You just need to right click this and copy link address. That's just what you need. Copy link address. If you want to see the link address, let me let me paste it on Word documents. Okay. Okay. Yeah. So yeah, you can see this is it. Um, so let's go back to our R. So to import it directly from the website, we need read underscore CSV. This function comes from reader. So what I've just done is just to insert in this code the website. You can see. Yeah. So let's run it. So when you are running and you have this red button here, then you have to wait a little bit for the work to be done. So it's a bit large data sets, kind of big data sets. Um, so I think it should be up to 40, more than 40 MB. Yeah. So let's look at few things why. Um, okay, yeah. Oh, fine. That's all right. So it's done. So we have the data sets. Now we have so many countries. The next thing we quickly want to do is to extract Nigerian data on total cases from February to June year 2020. But let's quickly look at the column names, the names of the variables there. So we have 67 variables. So some of those variables include the continent, the ISO code, location, that is where we have the list of the countries. Then we have dates, total cases, and so on. So I want to obtain a new data set. I call the new data set NIGD, which is equal to this. I want to extract it from this COVID. Um, then I need this chain operator. In layman language, just say then, that is, I have this COVID, then what do I want to do with it? So I want to filter location, that is, I want to extract Nigeria from location variable. Then I need to limit the date to less than July 1, that is from February to June. Then select just three of the variables as location, dates, and total cases. This is what this code is saying. So I light it here and run. Good. So the moment we've done that, then we can export it. The new data set now, we can export it to Excel, and it's going to be, and we can find it with ease in our working directory. So let's run this. Okay, fine. No, it's talking of permission denied because I already have it there. So maybe we can give it another name because I already have it there. That's why it's complaining. So let me add one to this. Says no, it's going to do it again. Yeah, you can see. So and if you want to see the data sets, so it's already in the time series training. So this here. So look at it. This is the Nigerian data sets. Yeah. So this is the data sets, location, dates, total number of cases. Yeah. So let's go back to our R. So now we can plot. So to plot the graph, we just first need to convert to zoo. To do that, I call the new data set. No, what the beauty of R is that you can have as many data sets as possible. Just give them different names, so you can have as many objects as possible. So now I create another one, call it NIGD underscore Z. So zoo. I'm interested in total cases, so I said NIG day dollar. This is the total number of cases. If you type NIG day dollar, it's going to give you list of all the variables. Then you pick total cases. Let me show you that one. So that's what I'm saying. NIG day dollar. Yeah, you can see all the variables. So you pick this. Simple. Then I want to define my dates. So sequence, that is from as.dates from February 1 to as.dates May 30 by equals to 1 to show me that it is I'm dealing with daily data sets. So the moment you've done that, so let's run it here. Oh, lest I forget, usually we use arch here to anytime we want to um, make comments. Yeah, it's not going to, when you run it, is because hash is there, it's not going to affect your results. All right, so we've done that. So now, since you already have the data set, you can now auto plot. So auto plot this. I add this team minimum. Let me first remove it so that you will see the reason why I added it before. But so let's clear this. You can just see auto plot so that I'll be explaining. If you just see auto plot, it's going to give you the graph. There is no big deal about that. But I will explain the other. So we already have it. So you can see our plots. But if you look at the plots here the y-axis is named NIGD underscore Z. And here we have index. So you may want to change those names. Then again, you may not like this color. You may want to minimize the theme. So in case you want to minimize the theme, that is why we have this plus theme underscore. I have so many of them, but minimal is what I normally like. So if you do this, yeah, you can see. Yeah. Then I may want to, here you have February, March, April, May, June. February for which year? March for which year? April for which year? May for which year? June for which year? So this is the essence of this scale underscore x underscore date. So that, let's say I say date breaks, yes, I still want it to be on monthly basis. But now, this command, you have the labels. I need the label just the way it is. This is abbreviation for the month. If you want the full month, this will be capital B. I will show us that one later. But I want the year to be added. So it's not just February. I want February 2000, March 2000, April 2000. Because there are times when you may have more than 1 year. And even if you don't have more than 1 year, it's always still good to indicate which year you are dealing with actually. So that's the essence. So let me remove this. This is the beauty of, we call it grammar of graphics, the GG stuff. Yeah. So run. Yeah, you can now see this is February. You can see now that the year is already included. If I want the whole, if I don't want the abbreviation, I want February to be written in full, I will change this to capital B. So run it. Yeah, you can see February 2020, next one and so forth. It's full now. If I don't want 2020, let's say I just want February 20, March 20, that is, I just want maybe the last two digits. Then I change this one to small y. So you can have a lot of variation. There you can see. So keep changing, just depending on your choice. Um, yeah, let me go back to, and in case you want to learn more about scale underscore less underscore dates, just type ep and put scale underscore s underscore dates within the brackets. There's going to give you details so that you can learn it on your own. So let me go back to this. Fine. Yeah, those are the last thing I'm adding is the label. Oh, yeah, I want my y-axis to be labeled number of cases and my x to be labeled time instead of index. So if I've done that, that's why I say plus labs. Labs means label, so run it. Fine, you can see that it has changed. So then you can export it, export, copy to clipboard, then copy plots. So you have done this, then you can have it in your um, so you can have it in your Microsoft Word. Let's right click here, paste. Fine. Yeah. So let's go back to our R. So we may want to include our regression line. You see, we are dealing with two variables here. We have time, then we are dealing with the total number of COVID-19 cases. So we may want to actually impose on the graph um, the regression line. So if you want to do that, then we need to add that's why we have geom underscore smooth. Method is linear method LM. Then plus we have start underscore reg line underscore equation. We can get this function is in ggpub. Label.y. Label.y equals to 20,000 because I want the equation to be written in front of this 20,000 here. Then start underscore core, that is how to write my R square. So I say AES label equals dot RR dot label dot this is my R square. Then I want the label to be where? Around the 18,000. So if you have done that, then let's run it and see. Um, yeah, I think we start from here. Good. Fine. So now we can see this is our regression equation here. And this is the R square, which is showing you that actually uh, trying to explain almost 79% variation in total number of cases for COVID-19. It's serious. Yeah. Oh, yeah, we can see um, this. You can remove the standard error here so that you just have the line if you so wish. If you want to do that, then you come here, where you have SE equals to false. Yeah, to do that, it's going to remove the standard error. Yeah, and again, you can export it the way we've done. All right, so another way to import data set from R is from the website is the use of quando. If you don't have it, you install it. And if you don't have any of those software of those packages, it's simple to install. Just come here and say tools, install dot packages. So it's going to give us a box. So, and inside that box, we will type um, the packages. Okay. Okay. So here, let's say I don't have quando. Just say Q U. You can see A G is quando. Yes, quando. This is it. So you just need to pick this. And let's say you don't have other ones, just put comma here, then you add other ones that you don't have. Um, take for instance, if I don't have tidy verse, just pick it here, and so on and so forth. I have them, so I don't need to install them again. So, but after installation, then anytime you want to use the package, you type library here because it's already stored in this library here. So, Quindle, that's what we want to use. Fine. So I want to show you. So let's minimize this to see how we normally use it. So let's come back here. So there's Quindle. All right. Okay, in my Google, I just type Quindle. Let's say my interest is oil prices. That's fine. Here I have a website where I can get crude oil prices from 1861. So let's open this website, for instance. Yeah. Yeah. Okay, it's fine. Yeah. So the only thing we need, you come here, you can see next that data link code. This is just the code you need. Just highlight this code. Bam. Copy. Just copy it. Copy. Then come to R here. So you can see this is what I call OI2. Quando, just put it in the bracket here. So I did that also. There is another site where I have this site, this another site. But for that site, this is what I've copied, paste. Yeah. So you run. It's extracting the data straight away. So now it's already extracted. You want to see the data, you have it here, OI2. Yeah. So you have the date, price in contemporary dollars, and so on. So, and at the website, if you are interested in specific countries, then you click those countries, it's going to give you the Quindal code for which you are going to download it. So that's another way. Now let's go back to our code. Sometimes we may be interested in aggregating our daily data. For instance, we are dealing with daily COVID data sets. We may want to aggregate to monthly so that we want to know the total number of COVID-19 cases for various months within our time frame of analysis. So if we are interested in that, we converted the data to zoo from data frame. So the starting point is convert the data back to data frame from the zoo. So this is what I'm trying to do. To do that, we just use fortify.zoo. That's a command in the zoo package. So, and to learn some of these packages, you just need to click packages here. There is no need overstressing yourself about uh, package to use. You just click on packages. Then you locate the package itself. So, like I'm trying to work with zoo here. So I locate zoo. Zoo, that should be the last, about the last under user. Okay, this zoo here. So click on it. So if you click on it, it's going to give you the documentation. This is the user guide in case you are interested in the entire user guide. So you have all those things that we're talking about here. Like fortify.zoo. I have that will be here, fortify.zoo. So is it. So you click on it, then you can read through all these things, or you go back, you go to examples, so you see an example of how to use it. So it's straightforward. So now I've converted the data back to data frame. So let me do the conversion. And I call the new data set NIG. So you can look at head NIG. Head means I want to look at the first 6 observations. So this is it here. Now you can see here I have year, month, and day. So since I need monthly data, I want to break this date to year and month. So that's why I said, okay, create a new column. This is how to create a new column, NIG $year. Create a new column called year. Then this is a function to break this time. So I said NIG underscore index, then create the column Y. Do that, create another one, months. So that's just what I have done here. So let me run this, for instance. Run. Okay, fine. So, okay, try the head NIG again. Let's see that. Yeah, you can now see. I now have a column on year, I have a column on month. And this is showing me the forces observation. So that's how to handle it. So now, um, now if I want to handle the aggregation, it's very straightforward to do. Or let's call the aggregate as AGGNIG. Aggregate what? This is what I want to aggregate. Because I want this, please help me to calculate the total for various months, maybe total for February, total for March. So this is what I'm trying to say. Months plus year, comma. My data list NIG, then function that is FUN, sum. I want to get the sum for month and year. So run. So let's get the forces observation for the aggregate. Yeah, you can see. So now the total number of cases in February was 379. For March 2020, it was 14,780. And for May 2020, it was 459,958 cases. Yeah, so that's as simple as that. Um, Another way to do the breakdown is to use float dates, but I think what we have done is pretty simple to understand. So let me just cancel this. That's not to be confusing ourselves. Yeah. So that takes us to the next thing we quickly want to do, that is plotting of monthly data sets. And we shall be using another data set. I sent the data set to us if we have fully registered and paid. Um, so to get the data set, just come to File. Since you already set your working directory, so you look for it. Which means if I were you, all my information, the data set, the book, everything, I will put all of them in one folder and use the folder as my working directory, because that is what I do. So here is the claim that if I want to import this, I click on it. I say import data sets. All right. So import. So these are our data sets, start from 1979. This months, so this 1 to 12. Then you have the maximum temperature. You have the minimum temperature. Then you have the precipitation. Yeah, it runs up to, I think, 2018. Yeah. So let's go back to our code. Um, if you want to plot this time series data, you must first convert it to time series. And in this case, we are dealing with monthly data set. So the easiest thing to do is um, use TS to do the conversion. So I call the new data set as TX underscore TS. TX, this is climb that dollar. Let us deal with maximum temperature. So starts equals 1979 January and frequency is equal to 12 to indicate that we are dealing with monthly data. So let's run this. Pretty simple to do. We want to look at your data set. So this is the data set here. So you should have it for various months. So we have January, February, March, April, May, and so on and so forth. So the moment you have it, then autoplot, just autoplot this. This is just labeling my y-axis. So run. Fine. Don't forget, you may wish to remove these colors. So you can add if you want to do that, let's say plus team, that's called minima. Run. Fine. Yeah. Then again, you can add the center moving average. So if you want to add that one, it's very simple to do. You do that by adding geom underscore MA. And you define the moving average, this simple moving average. And I'm using 12 months. So that's, I'm using the center moving average. So you want to do that, so just run so that you can see the trends. Yeah, you can see it. Yeah, but now you have all these plots, it contains the trend, the seasonality, the random variation, everything, and the data set, everything is in the data set here. So you may want to, if you want to get a clearer view of the trend, because here you are not getting the trend clearly, apart from this moving average that you can see. But to get a clearer view, then we can remove the seasonal effects by aggregating the data to annual level. That is, you can convert to annual. So if you want to convert to annual, it's very simple to do. I call the new data set AGG underscore TX. So the aggregate, that is the function. And then let us not forget here we are dealing with maximum temperature. So I divide by 12 so that I'll be able to get the mean uh, for each year. So then if you have done it, so you can look at it this way. So this is your data set. So it's time series start 1979 end. Now frequency is 1 because I've converted everything to annual. Then you can auto plot. You're already familiar with that, so run. So it's that you can clearly see, you can now see the trend clearly. And anyway, you can say, okay, T underscore. Oh, well, let's try classic this time around. Yeah, run. Yeah, so it depends on whatever you want. Okay. So another thing we can do is that we can look at the values for each season using box plots, and we use cycle to extract the seasons for each item. To do that, it's pretty simple. Just use box plots. This is our data as a function. Locate where you have this function on your system. Usually, it's very close to escape on the keyboard. Check it. Yeah, cycle is our data set. Then you can use any color of your choice. If you have done that, yeah, now you can see. So this is extracting the value for each season. This is the 12 months. So this is clearly showing us that we have the lowest temperature, maximum temperature in July. And if you are thinking of month when you have maybe the hottest months now, that would be from you have something like November, December up to February. Good. So another thing of interest, maybe we may want to look at what is going on in a month or two, instead of looking at the whole data sets. So if you want to do that, then what you need to use is window instead of TS. So this function extracts the part of the time series between specified start and endpoints. So let's say our interest is January, for instance. I have window. This is my data. Start. This is what I want is January, which is 1979. Frequency true. If I do this, I'm just going to have January formation alone. Yeah, just January. You can plot it if you so wish. So another thing we need to quickly learn is the composition of time series data. The composition of time series data. So to decompose is very simple. I call it decomp underscore client. You can call it any name of your choice. The function is decompose. Very straightforward. So I decompose. So if I decompose, let me plot what I've done. So I say plot. All right. Okay. To see it clearly. So let me say plus team underscore minimum. I like a minimum. Yeah. Well, okay. It's because sorry, we should add plus minima to auto plot, not decompose. Cut. Sorry. So this paste here. Okay. Maybe it's not supported. No problem. So let's look at the decomposition. This is additive time series. So we have the data, the trend, the seasonal. Then this is the random variation here. So we have all of them. And we can isolate the seasonal plots by using GG season plot. I explained that one in the PowerPoint. So let's run this. We see clearly how it's done. Yeah, because it's going to show us the seasonal plot for various years. Um, is it taking some time? Yeah, fine. So here we have the seasonal plot for various yeah, and we can see the trend. Usually if you look at it, just as we explained earlier, uh, for most of the years, we have the lowest temperature around July, and you can see a kind of steady decline in the maximum temperature from January up to June. You see a steady rising from July to something like December. So this clearly showing uh, a better view of the seasonal variation. Then we need to look at the lag plot. We want to plot the lag plot, the plot by various lags, as explained in the PowerPoint earlier. So it's just UGG lag plots. Yeah, so this is it. So you have the lag plot for various months. Yeah. So what we need to do now is to look at our first assignments and try to go through it. Uh, we already have the PowerPoint. Then we have the script file, so you can work with it too and work it out so that by the time we meet again, definitely we look at our results, and wherever we have difficulty, then we are going to look at it together. So thank you.